Hello, my name is Ariff Kenichi bin Ahmad Zaki Akira from RI41, matrix number 1913925542. In this video, I'm gonna present or talk about the mini project for the PGT 212 electronic communication. So for my mini project, I've been given the title of the third order active high pass filter. So So intro for the introduction. So there's several things we need to know for before we start doing the order high pass filter. So first of all, uh, active filter. Generally, active filter use an amplifying device such as a transistor or an operational amplifier. So in this uh, video, I will be using an operational amplifier. So for the passive, actually, uh, it doesn't use any of this amplifying device. So such as resistor, capacitor, inductor. So there's several advantage when using active. Basically, it can have a better gain, greater gain than unity. You have high input impedance with low output impedance. It's very feasible to cascade and many filter for improvement performance. It also can combine with the buffer amplifier, or we can call it voltage follower, to isolate each stage of the filter. So that is about active filter. So for high pass filter, there's several type of filter. We have low pass, high pass, band reject filter, and all pass. So basically, is stated here. So low pass means it's allow frequency that is low to pass. High pass is basically high frequency to allow to pass. So band pass is around the center. It's basically the combination of low and high pass filter. So the band reject, or we can call it band stop, basically the vice versa for band pass, and all pass is basically allow all. So this the high pass. For the high pass, basically allow high frequency to allow to pass through. So for first order, basically it's gonna be 20 dB per decade. So 0.717 here the theoretical. So we can calculate for the first order using this formula 1 over 2 pi RC to, to calculate the frequency, the critical frequency. So we can calculate the gain by following the modulus V out over V in. So to find the gain in decibel, just uh, 20 log with the gain. So methodology, this is the circuit diagram. Uh, I will show you in the simulation. So this is the uh, the circuit. So we have here is oscilloscope, OP amplifier, OPM, two of them. Since it's three order, so we have three set of RC. So this is the function generator. So what I did is basically when running the simulation, all we need to do is just change the input frequency. So right now it's set to 100k. It's gonna we just gonna take just gonna measure the VP the V voltage peak to peak. So just the output. The input theoretically you're gonna constant all the way. So just gonna change the input only lah. So let's continue the circuit analysis. So basically this is the first order. So like I said just now, it's basically RC, but the capacitor is in series and the resistor in parallel. So this is it's gonna look like this. So to calculate the critical frequency is 1 over 2 pi RC. So in case of second order, as you can see here, is two set. So capacitor, resistor here, capacitor, and this the one set, and this the another set. Okay, this is the circuit. So basically, in case of the basically the critical frequency is 1 over the formula is 1 over 2 pi square root RA, RB, CA, CB. Basically the first set of this example here. So this is the first set A and B. So in case of RA and RB and C or CA and CB is equal, we can use the basic formula. So 1 over 2 pi RC. So from the circuit that I create, so basically I make all the capacitor and resistors the same. So generally I gonna use the 1 over 2 pi RC formula. Take note also to design third order. So in case of first order, we just gonna put 1 OPM. Second order, just 2 OPM. So in case of third order, we're gonna use 2 OPM. One is the first order and one more is the second order. So in case we have 4 or 5, so basically we just gonna use either the first or the second order. So if example we want the fourth order, you just take 2 or second order and second order, we cascade it together, as you can see here. So the result, like I said just now, I just gonna change the input frequency. So I've taken uh from 100 to 100k frequency kilohertz. So 100 to 1k, then 1.5, 2k, 5k, 1 10k. Then from the simulation, the voltage input is the same throughout the experiment. The voltage output is changing when setting in the frequency. So as you can see here, it's increasing. The gain is basically V out over V in, and the decibel 20 log gain. And this is the result that I have obtained. Okay, I have drawn a graph. So this is the result that I have obtained. A high pass filter, simul high pass filter, the curve. So minus 3 dB here and here. So I get is 2k kilohertz for the pass band. When I do the calculation, 2 pi RC, the critical frequency I have obtained is 795 or 0.775 hertz, and it should theoretically it should look like this. At this frequency, you're gonna pass. After this frequency, you're gonna pass. But in the simulation I obtained after the 2k, it's just allowed to pass the frequency. So from the result, based on the result that I've obtained, the theoretical and the experimental value have different values. There's several reasons why it might be different. Firstly, the calculation for the theoretical calculation doesn't come into consideration with the tolerance of the capacitor component. So some resistor or capacitor have their tolerance value, so it might be affect the reading a little bit. But the major reason why the result from the simulation and the theoretical is different in my experiment is probably because of the operational amplifier or OPM. Since OPM, there's a lot of OPM. So in this experiment, I've used a 741 OP amplifier. We have their own uh, value or characteristic in the data sheet. We can refer through the data sheet. So this might be the reason why I have different because of the limitation of the OPM. So in conclusion, I successfully designed and analyzed the active third order high pass filter using the concept of using the amplifying device. So when using designing a third order filter. Basically have three set of filter, three set of RC circuit to make. Then we combine in the cascade using the OPM. So that's all from me, and thank you.